Okay, so continuing with UAV platforms, let's dig into a real and well-known electronic intelligence airborne example, airborne product, let's put it this way. Well, first of all, please find attached the datasheet linked below. Okay, so we have the Ultra Eagle ALR 510 and its main state-of-the-art features we could list are the following. Is integrating ESM systems on ELINT systems for improved probability of interception and immunity. Attach and derive basic schematic describing each system and each sensor as well as the mission computer navigation system and data link towards the ground station and respectively workstations. Moreover, right bottom, a preliminary location of these systems is shown. Where were you expecting this kind of integration? Are you familiar with these platforms, this unmanned platform? Can you distinguish between ESM and ELINT? Tic tac. Yeah, I hope so. I hope so, and I'm pretty much sure that you can distinguish by now what are the difference, the main difference. So I will help you with that. ESM high provides with large instantaneous spatial field of view, high probability of interception, and intermediate bandwidth. Okay, so here we can give the example of instant digital instantaneous frequency measurement receiver 2 to 18 gigs. So that means 16 gigs of instantaneous bandwidth, which is incredible, which is amazing. The ESM is also integrating the omnidirectional antenna plus radar warning. And what about ELINT? Well, ELINT with high direction finding accuracy, interferences, immunity, and low probability of interception techniques. Okay. In this case, we have four channels, super heterodyne receiver 0.5 to 18, half gig of instantaneous bandwidth, minus 75 dBn sensitivity, more or less, and around 1 degree RMS direction finding. When it comes to sensors, we would be talking about linear interferometer antennas plus a spinning antenna, okay, which can go all the way up to 40 gigs. Third bullet point related with ELIN, we have extensive threat signals parameter extraction. Okay, that's basically the big advantage of ELINs. So now, are we clear with the differentiation between ECM, ESM, ELIN, and also airborne platform integration? If not, just take your time and rewind this section. Okay, it's important to have it clear. It's important to have it clear. So go step by step, take your time and read it carefully. Okay, so provided here we have more data sheet. We have this one from Telemus. So go check this out. This will help you connecting all the concepts and dots that we have been discussing along the course. Briefly, yeah, we can go through it together, just super quick. So starting from our left, we can see what we mentioned before, the whole schematic, basically ELINT and ESM, okay, architectures. You can find your interferometers, you can find what we mentioned before, your fourth channel, in this case is tuner, typically we call it fourth channel, digital receiver. Um, Then obviously this RF is controlled, digitalized, processed, and typically ends up in a recorder database. Okay, nothing new. It's basically a good illustration of what we just talked about. On the bottom one for the ESM, we have this omnidirectional antenna, different switches, digital, I can read right away, digital front end, some Ethernet links, and obviously everything is data linked, or everything is connected by Ethernet, high-speed Ethernet to a mission computer. Okay. Now we're right. We just have more data sheet that I will give you as a homework. Quite sure, commercial data sheet. Okay, quite clear. So just check, especially the terms that they mention. Okay, and try to find the connection to the theory we just explained. Okay, guys, now what about ground station? If you remember from, I think, two slides before, all UAVs require a ground station, right? An operating workstation linked by, yeah, the so-called data link. Let's describe the main functionalities required from the respective ground control stations. Complementary, please refer to the screenshot on your right, typically ELINT mission software used by the operator. Okay, just keep it in mind. Have a look into these pictures. Um, Main features, ground station. Firstly, ground control station software. We have different modes, different visualization, okay? Different plots, different parameters. This is different ways of showing the intercepted signal, the spectrum, the environment. Secondly, it is automatic, which means it enables the user or operator to set up and select an automatic, fixed, linear, or complex search schedule. This is automatically happening. Supports emitter automatic track management, identification, and parameter list EPL. Moreover, it provides direct control of the connected system and equipment. So sensors, preamps, digital receivers, everything is controlled. Collection, another feature. It enables an operator commanded recording on radars of interest. This is what we call collection, with or without digitizer samples. We can also record in a database on a UAV, and later on this recording shall or is transferred to the ground station. Finally, advanced graphical analysis. Okay, this can be done automatic so that the parameters analysis tools are provided. Quick description of these pictures. As I mentioned, this is the typical software. This is the yeah. There is no more explanation than that. Is a classical software. This is what the operators are working with. Okay, starting from the bottom, we have a emitter track list. Okay, you can see there. You can see there basically different threads, okay, different emitters with different powers, frequencies, pulse repetition interval, different modes, pulse width, angle of arrival. You can see there is no explanation needed. This is a list of emitters with different parameters, intercepted parameters. Okay. There is on your right, bottom right, is quite cool because you have different spectrums, time domain, frequency domain. You have these 360 degrees kind of radar or sonar where you will visualize all the threats. Um, so yeah, I'm not familiar, especially with this software, but I'm guessing I have seen something else. Okay, so I would say that there's so much flexibility when it comes to different windows, different parameters, different ways of visualizing the intercepted signal. Okay.